Okay, thanks very much, Steve, and thanks for the invitation to come and talk about the F-35. I'll just have a comment on Doug's talk about the 9/11. I was visiting and spent a bit of time at the Pentagon in my service career, and I was talking to my colleagues who were actually there on the day they got hit. Interestingly, they were in another part, obviously, and I said, what was the effect on you when you heard it? And they said, we didn't even know that it had been hit in part of the building. They were around the other side somewhere. It's obviously a pentagon shape, and it's actually multiple pentagons within each. And they said they just started to notice people panicking, running around, but they didn't actually hear it or see it when it was there. I went to a little while later. We had to get special permission from our generals to fly over to the States while those embargoes were on, and for the flying. And I travelled across the States on a commercial airline, but they'd cut out all food. You had no knives, no anything. They'd give you a packet of pretzels to eat. And we got searched as foreign nationals in every airport, body searched. It was, and on the night it happened, I was leading a review in Canberra, and I had two Americans on the team with me, and we got the word, saw it. We just got back from dinner and saw it was witnessed on TV, and that night they got the call to go back to the USA, but they couldn't because flying was banned and there was no way to get back. Okay, today I'm going to give a talk to you about the F-35 Lightning II aircraft. This has come from my experience in being involved with that back in its stage of development, what we call the SDD phase, where system demonstration and development phase, which goes between contract and when the aircraft becomes operational. Some of you may or may not know that it's today's premier fighter, stealth fighter, but the contract was signed in 2001, so even that now is 22 years old or 23 years old since it started its development, and that followed a competition between Boeing and Lockheed Martin. Just be out of interest, how many ex-Air Force pilots are here? A few. Navy? You Australian Navy? Any? No? I just want to know how many lies I can tell. Yeah. Just quickly, my background. I'm actually over here for an Air Force reunion with my colleagues. I joined the Air Force 62 years ago in 1962. So anyway, we'll be having our 62nd year anniversary, and it was celebrated in Mandurah, so that's why I'm here. Glenda and my wife, who's also ex-Air Force, we've been at the reunion down in Mandurah, and we come from Fraser Coast, Maryborough in Queensland, which is about 2.5–3 hours north of Brisbane near Fraser Island. My background, as I said, was 20 years in the Royal Australian Air Force. I was an avionics engineer, and I retired at the end of 20 years in 1982. I spent a few years working. I was a site manager for Bombardier and built the electric trains that actually run to Mandurah. They come from Maryborough in Queensland. And then went back into the Department of Defence, and I worked with the Fleet Air Arm for 7 or 8 years on the introduction of the F-70B2 helicopter, the anti-submarine warfare helo. I stayed in the department for 35 years, and the last 22 of those I was a technical director in the Department of Defence and involved in the acquisition of quite a lot of systems. My F-35 particular involvement started about midway through its development, when they had an inflection point where things started to go wheels up, and I was called in to lead an assessment to make a determination whether they should continue with the purchase of it, and I'll talk a little bit about that later. As a part of that experience, we were amazed at how this multi-billion-dollar project was being run, the size and scale of it, and my colleague, who was a doctor, Betsy Clark from the USA, and I were doing these reviews. We decided to write a case study for program management because it was the world's biggest defence project ever at that point in time. In doing that, we've interviewed over 100 senior leaders in the Department of Defence and in 8 partner countries around the world. and I was interviewing Tom Burbidge, who was the president of Lockheed Martin Aeronautics, and then he became the program manager of the F-35 and general manager for Lockheed. He was also formerly the general manager and program manager for the F-22 Raptor. So he'd built both stealth fighters that are operational in the US today. When we were interviewing Tom, he said, "I'm glad somebody's writing this story," and we said, "Why don't you join us?" And so he did. And that brought in a wonderful archive of material and knowledge to what we thought was going to be a case study, and we decided to make it a book and tell the human story of how the F-35 has come to be. We launched that book last year at the RAAF, the Royal International Air Tattoo in the United Kingdom in the Cotswolds, the world's biggest military air show. And we've sold a few thousand of those books, I think, since worldwide. Okay, so what is the F-35 Lightning? It's a fifth generation jet fighter aircraft. It's a stealth aircraft, which means that it's very difficult. It's not impossible, but very difficult to be detected on radar. And there's a number of reasons for that. One is the material that the aircraft is built out of. It's got titanium metal spars, but cladding on the aircraft is not metal. It's a special composite material that has embedded radar absorbent material that gives it the stealth categories. They say it has the radar cross-section of a golf ball. It's pretty hard to detect, but not impossible. Designed by Lockheed Martin in the USA, and this is the first time the Americans had opened up the programs to allow partner countries, allied partner countries, to participate. The reason they did that is that they started to realize that having the superior technology that they do have and has had over the many years, and generally meant that when something happened, they were the first to go in because they had the superior technology for the allied services. They said, if we open it up to our trusted allies, then we can share that burden of being, taking on being first responders to conditions around the world. And so they did. And there are 8 partner countries that joined them. Australia being, I think we were about the last to do that. The other countries, you'll see in a minute. There's 3 F-35 variants. So we talk about the F-35, but it's actually 3 variants of aircraft. There's not just one aircraft does everything. However, if you're sitting in the cockpit of any of those variants, you couldn't tell the difference, except in the STOVL. There's one more lever that they have to go into STOVL mode. The rest is identical. The mission systems and weapon systems on board are identical on all 3 variants, but there are physical structural differences. For instance, the carrier version needs to have beefed up undercarriage and to be able to withstand the stresses of catapult launch and arresting through the cables. At the moment, and the F-35 is in production at the moment. They've built about 1,000 of them, and the program employs roughly about 214,000 people worldwide. And this involves Australian companies, and so far about 50 Australian companies have been involved. And the contracts, when I left Defence about a year ago, the number of contracts let in Australia was to about 50 companies overall so far, and that brought in so far about $3 billion into the Australian economy. Production is to continue probably into the 2050s, so that's good for our industry because they're going to have a long-term involvement. They have to compete on best value against other partner countries in the world. Only partner countries in the program are entitled to be involved in the industry side, and there are 9 of us. And so no other, even if they buy them as foreign military sales, the other countries aren't entitled to provide parts. This is a bit textual for the moment, but there are more photos later on. It's called the Lightning II. The reason it's called the Lightning II is that it's the second Lightning for both the US and the UK, who are the principal partners in developing the program. The first was the P-38 Lightning, built it around the end of the World War II and was a pretty efficient aircraft, I understand. And the other was the English Electric Lightning you see there, the right-hand side, which was predominantly an under-over engine configuration. I think they said there's an advantage to having under-over, and being a electronics guy, I can't remember what it is, but some of you may know. There was some efficiency gain from that. It was intended to be used by the UK against the Russian Bear bombers, etc., that were high altitude strike aircraft, and this Lightning predominantly only carried missiles, and they could launch, and it could go supersonic in a climb and chase the bombers. There's an interesting story that went along with that. As a wing commander engineer doing an engine run on one. This is a true story, and he was strapped up. He was sitting on a box because they had the ejection seat out, and something happened, and he inadvertently, when he was running the engine up, it started to taxi, and off it went. He went down the strip, just missed a cross-strip aircraft that was taking off or landing, and went airborne. So he was airborne without a helmet, sitting on a box, and apparently he did a circuit and got it back down successfully. He had some flying experience earlier, but he was an engineer, not a pilot. And that was the English electric version. Just interesting, excuse me, the three variants, and I'll tell you what they are in a minute, of the F-35 are all built on the one production line. The aircraft come down the line. There can be an F-35A on one position, and then the one following that could be a C model, a carrier version, or the next one could be a Stovall version, and the one production line can deal with whatever one comes through the line. And I'll show you some photos of that line because it's pretty impressive. Interestingly, there are 9 countries involved in the partnership to build them. Today there are 20 countries buying them and using them. The Ukrainian war gave a hell of a start to a lot of the European nations, particularly in Northern Europe. And so suddenly when the Ukraine war started, about 5 or 6 countries decided to buy them. And so you have the 2 countries that were partners up there, or 3 countries, were Netherlands, Norway and Denmark. Now you've got Sweden, you've got Germany, you've got Poland, you've got Czechoslovakia, and a range of countries are operating them. And they're combining with the Canadians and Americans now and doing patrols in the North Arctic area, because the seas are melting with climate change, and the Russians now are having more sea access to countries, and it's causing a lot of concern. We have 72 F-35 fighter aircraft. 2 squadrons are based at Williamtown in New South Wales, and 1 squadron are based at Tyndall in the Northern Territory. Also at Williamtown there's an operational conversion unit or a training squadron as well to train the pilots. The aircraft, they were to get more. Our program of record was for 100 aircraft, but about a week ago the current government decided they would not buy more and rely on the Super Hornets that we have to keep that gap filled there. So at this stage it looks like 72 will be the max number. Typically we've had up to this point around 100 fighters, but today we've got 72 F-35s, 24 Super Hornets, 12 Growlers, so it's still a pretty formidable force for a small country. When people talk about the F-35, some of you may be aware there's been a lot of negativity in the press. A lot of it is misinformed, and a lot of it is totally wrong. The F-35 was developed along with the advent of social media, which gave voice to people to give their opinions, and a lot of them did that who were not knowledgeable about it, and other people believed them, and that way it went. And so a lot of the social media comments are quite negative and totally misinformed. The cost of them is very expensive. The program, when I was working on it back in the mid 2011 through to about 2016 or 17, that was about $400 billion had been spent. The life of type cost they think is going to be about $1 trillion, 1,000 billion. However, you can see here the aircraft that it's replacing, and these aircraft are the current generation aircraft that are in service around the world. Those costs to replace these with those 3 variants is expensive, but imagine the cost if we had to replace all of these individually for their current role. The F-35 can perform the role of all these aircraft. You've got the Warthog, the ground attack, anti-tank aircraft, You've got maritime aircraft, the Harriers, you've got the Hornets. Nighthawk was the first of the stealth aircraft. The F-111 that Australia operated, I was heavily involved with those. I picked the first 6 up in 73 and brought them back after we did trials in Edwards Air Force Base to Australia. And we buried those, and I literally mean that. We buried those in 2010. If you go out around Ipswich, there's a big grave full of F-111s. They had Thies, the contractor, dig a big ditch and put them in. They had a lot of material used on board, beryllium, asbestos and stuff. They didn't know, they were quite dangerous, and they had to get rid of them. We investigated smelting them, but you needed over 2,000 degrees, and nothing that hot, that big was available, so they decided to bury them. So these are the aircraft that the F-35 is replacing now around the world. You can see 2 of those, or one type of aircraft, which was the Harrier jump jet. The Marines in the USA fly those off their amphibious assault ships. They were the first vertical landing aircraft, but they don't go supersonic. The F-35 is the first supersonic and vertical landing aircraft. So just to summarise on that, yes, the F-35 is expensive, but if you had to replace all of these with their individual capabilities, it'd be probably more expensive. Plus the training, imagine the training, where you've got to train pilots and ground crew to maintain and sustain all of these. But if you have one type of aircraft, and then we share the logistics now across the world, the F-35 logistics system, it's called Alice. It's the autonomous, a day in the life of Alice, I'm trying to think of it. Yeah. It's a centralised worldwide logistics system. It doesn't matter where you are in the world with an F-35, if you're near one of those 20 countries, you can land, be repaired, replenished, relaunched, and the logistics is available to you from any partner country. So it's not as if we now used to only own our own spares. We now share around the world. If we've not got something here, they'll bring it in from Japan or Singapore or Korea or one of the other countries. So the logistics system now is worldwide, and that's a big advantage as well. When they started this program back in the 90s, they had a program called JASP, which was to develop the new generation, 5th generation fighter. These are the 2 competitors. On the left, yes, your left too, X-32. That's the Boeing competitor. We thought it looked like a big pregnant guppy. They had the air intake, they had the stoval capability, but it was all hot air. So that was relied on the engine. The way that was designed, it meant they had to place the engine in a certain position, and that gave it that funny appearance. The X-35 is fairly similar to what you see today. Both these aircraft had to be built and demonstrated to the US DoD and prove they could do things like become supersonic and land vertically. These aircraft didn't have all the mission systems and other things on them that they have today. It was just to prove the aerodynamic concepts of stealth, vertical land, supersonic and so on. Today we have 3 models. The F-35A, this is the one the Australians have purchased. If you notice on the port intake, there's a little bump just above it. Can you see that? That's a Gatling gun, only available on the F-35 A model. If I step down one, you'll see it there from above. The other 2 variants did not have a Gatling gun on them at all. They can put a pod underneath. They want to have a Gatling gun, but they don't have one embedded like this. That Gatling gun's a 4-barrel Gatling gun. It does 3,300 rounds a minute, but it only carries 250 rounds, so you haven't got that long. The reason that they're not too worried about them anymore is that they don't dogfight anymore. Americans haven't lost an aircraft in a dogfight for 40 or 50 years. And now engagement is not done face to face. Engagement is done 50 or 80 kilometres apart. You're not going to get into a situation where you need it. The material that aircraft's constructed out of is a composite material. That was developed as part of the program. That material came from the yachting industry. They found that and they embedded their radar shield and then put it out for weathering, and it stood up. Previous stealth aircraft have to have very well controlled climatic conditions, and they couldn't take them on carriers because they couldn't air condition hangars, and which they do on other, like the F-22 has to be maintained in an air conditioned environment and so on. This aircraft does not have to have that at all, so it can go to sea and be in quite harsh environments because the material is different to anything before. That's the STOVL, the short takeoff vertical land. They can take off vertically, and if it works, we have a video here showing you its first demonstration where it vertically launched. They can't take off with a full load of fuel and weapons. They carry about 18,000 pounds of bombs and rockets, and with a full fuel load it's just too heavy. But when they come back off their mission, they can land vertically and do. The carriers that carry the STOVLs, like the US Marines, do not have catapults and do not have arrestor systems. They rely on the vertical landing approach. The third variant is the traditional carrier version. You can see there that it is landing and grabbing the arrestor cable. They have normally about 4 or 5 cables across. The flight control system and the control laws are so good on this now that they can almost pick the cable they want to grab. It's they call it the magic carpet ride now. It's much better than any other carrier version aircraft, and it has the folding wings that to make room for more of them on board. Okay, so there's the 3 variants there. If you look at those, you'll see on the top left, that's the Air Force version, the conventional takeoff and land, and you can see that Gatling gun there in the port side, above the port side intake, which we don't see on the other 2. The other thing is that F-35A version, the fighter Air Force version, can be refueled by a boom. Boom refueling is a lot faster and a lot quicker than refueling by a hose and drogue. The other 2 get refueled by hose and drogue. If you look down the bottom, you'll see the configuration of the STOVL, and if you look just behind the pilot, you'll see a big fan. That's a Rolls-Royce cold air fan, and blows cold air down as part of the thrust. That puts about 20,000 pounds of cold air thrust. At the back, the nozzle from the afterburner drops down, or from the the jet turbine nozzle, and the 2 of them together is enough to lift the aircraft vertically. It's really big as a mind when you think of an aircraft going supersonic and then stopping and just dropping down and landing. So well designed that in the Harrier it took them something, don't quote me on the figures, I think it was something like 8 weeks to teach a pilot to land vertically, because they're quite complex and reasonably difficult. On an F-35 they're so intuitive they have to have no special training at all. My colleague and the book writer Tom Burbage, he himself was an ex-US Navy test pilot. Tom did a flight in a special Harrier where they had the 2 flight control systems, one from the original Harrier and a second flight control connected up in the Harrier for the F-35 system, so they could fly either one. When Tom took off after he'd retired, but they took him up in the second seat and put him into F-35 control. He'd never landed a vertical aircraft before, and he did it. He said, I'm ready to give it back to you, and they said, no, you can land it. He landed it. That saves a couple of months of training on the pilot. You'll notice the wing size of the carrier version, bigger, for obvious reasons. You want us to be slower in the approach on landing on the carrier, and it has stronger construction to handle the loads that it has to put up with in the launch system, catapult, and the arresting. Just some performance figures. This is for the F-35A. They're all similar, but obviously there's some difference. Wingspan, wing areas. The combat radius. It's got a combat radius of nearly 600 nautical miles. That's a fair radius. That means he can go out and come back and do that. His range, if he goes A to B, is about 2,000 odd kilometres or 1,200 nautical miles. For a fighter, that's pretty good. We were just talking before about the Mirage. You know, we used to have a 40-minute duration on a Mirage with supersonic tanks on it. It wasn't very much at all, even though they could go fairly fast. Internal fuel capacity's there. They fly at G rating of about 9G maximum, which is quite strong, quite high. Weapon payload, 18,000 pounds or 8,000 kilograms of weapons. Propulsion is a Pratt & Whitney F-135 engine. Its military power is about 20 odd thousand pounds, and its afterburner it goes up to about 40,000 pounds thrust. What I'll show you here is the three variants in their particular role. So this is the A model taking off. This is the B model. You can see him getting ready to launch. He's opening up. There's the big fan. Watch his nozzle at the back. You can put that down. That can go down to 90 degrees vertically. Here he is landing on the carrier deck, and that's how they land. They come in normally, and that's the carrier version of the catapult being launched, and then coming back and using the arrestor cable. So that's the three different types, but as I say, sitting in the cockpit with the weapons they've got, the load systems that they have on board are the same, and if you're in a cockpit they look identical. Current status of the program, I've sort of iterated this before, I think 20 nations are now operating them, apart from the nine nations that were involved in the development, including Australia, are part of those 20. We're nearly at 1,000 aircraft, and possibly we've made it already. These are the figures I got from Lockheed 1st of April. There's a number of pilots that have been trained. Most pilots from most countries are trained at Luke Air Force Base in USA. Our first 9 or 10 aircraft went there. Each country contributed some of their own aircraft, and the US trained the pilots there in their own aircraft. I think that all of ours are now back, and we're running our own training courses now for pilots in Australia. There's going to be 57 air bases around the world operating the F-35. 32 of those are now operational, more to come. The 12 aircraft carriers are now carrying them, they're deployed, and 21 are planned to have them. So you can see they're sort of pretty much halfway into their career. The number that they're going to build, the US, they're ordering about 2,450 of them, and then you've got all the other countries on top of that. So we're talking over probably 3,000 aircraft plus. If you take the F-16 around the world, that started fairly low numbers, and I think today they're up to about 6,000. So it's probably pounds to peanuts. This will continue as well to expand. The main production is done in Fort Worth in Texas, which I'll show you the site shortly. I've spent a fair bit of time there. The two countries are now assembling them. They're called FACOs, Final Assembly and Checkout. One's in Italy and the other one's in Japan, where they can assemble. They don't manufacture, but they can assemble the aircraft. So you've got three final assembly production lines, the main one being Fort Worth. The aircraft stealth, as we mentioned, to do that you've got to have weapon bays to put the weapons inside so you can't see them. You can't see them on radar because of that radar absorbent material around them. So here's a fighter with bomb bays, if you like. They carry bombs, they carry rockets. I'll show you the armament they can carry in a minute. This one at the moment, he's got just like sidewinders on his wingtips. They probably wouldn't do that if they were going into a heavily contested, well-defended area. This is just showing you the weapon bays. So he carries his bombs and his rockets in those bays. He can put them on pylons under the wing. These are the range of weapons they can carry, and at the moment they're expanding that considerably. New models of missiles and so on, but it's pretty impressive. And they do, as I said, they replace things like the A-10 Warthog, the ground attack, so they can do anti-tank, maritime anti-ship interdiction, air interdiction for Air Force and so on. That's the underside of the stovel. You can see the nozzle there, part way down. On the wing, you'll see some doors beside the main wheel doors. Those are what we call roll posts. The engine has two air feeds going out to the wings. They're called roll posts. one on each side. So they put about 3,000 pounds of air thrust, and they can roll the aircraft, and they can go back and forward, because if you look at the doors up under the cockpit there, that's the bottom of that cold air fan. In there they've got blades like a Venetian blind they can adjust, and that lets them go back and forward. And so they can manoeuvre it up and down, back and forward, left to right, roll it in their vertical approach. This is the Pratt & Whitney 135 engine. That's on a test stand at Pratt & Whitney's factory. That's a huge big test stand to hold that, with its up to 40,000 pounds of thrust. When they first put that on there and started doing test runs, it started to crack the cement where those mounts were. On there you can see the two intakes up the front of that engine, simulated there with inputs, and then there'll be other test equipment and stuff around it. That Pratt & Whitney had to develop that to fit the three models. That's the same engine, and the life of that engine is the same as the life of the aircraft. The aircraft's got an 8,000 flying hour life. The engine has an 8,000 hour life as well. They're not making it at the moment, but that's its design goal. If it worked, you'd have the engine not having to be changed in a lifetime. This is the engine. You can see the roll post off to the left and right of the engine, or off to the port and starboard side, that you saw coming out of under the wing. At the front, you'll see the drive shaft going out to a clutch and a gearbox. That's a 90-degree gearbox. That engine shaft is running it when it's in power. He's running it around 26,000 RPM. That clutch has to grab that at 26,000 RPM and start the fan. There's multiple fans, so they don't have the cyclic forces. You've got to have one to counter the. So if you only had one, it'd one to turn the aeroplane around like a helicopter. So that's the Stovall engine configuration. I think the nozzle and the fan are built by Rolls-Royce. The engine itself is built by Pratt & Whitney. This is an Australian product. When they want to do an engine change, they'd use this engine. It's been designed and specified to allow one man to do an engine change on a ship in Sea State 5, that trolley and stand. It's got over 4,000 parts in it that they had to manufacture to make it. The last time I looked, before I left Defence, I think they'd sold 100 of them. They're $2 million each. And this is a team that I was with there. We're in the factory at Eglin Air Force Base down in Florida there, doing an investigation. That at the side they can have the old railway thing, you push it back and forward to move it, and the engine can be moved in elliptically and lining it up to put it into the aircraft. But it's interesting, there are two major companies in Australia who've got contracts, Moran and Farrer in Brisbane. Both were involved in the car industry, and when the car industry production started to drop off, they went for aerospace. They're now international aerospace providers. They've done really well. Interesting to see how they've changed their industry from. And Moran were so impressed. Tom Burbidge, my co-author, visited them and was very impressed. And in fact, he got them to send some of their engineers to America to help design the robotic automation for the production of the aircraft. And so some of the Australian companies have actually shined in the program, which is good to hear. Tom Burbidge had to arrange this 1,650 companies around the world to provide parts. They obviously all expected some industry input. That's why he called it the miracle of the loaves and fishes, because he had to divide it up. So there's just a chart there showing you who's making what bits. That's changed since this chart was produced. Australia's making some of this on the chart, but they're making more now. This is the production line with not much in it. I'll show you one where it's populated in a minute, at Fort Worth in Texas. And there it is. That's a mile long, that production line. When you work there and you've got to go up the other end, it's a long way. They ride push bikes and have electric cars running up and down. At the moment, the production, they've just been approved to go into full rate production. They're building 156 a year. That's pretty amazing. So what that means, they have about a 300 a year production days. That means you've got about one aircraft coming off this line every 2 days. At the bottom you can see them going up the other side. At the bottom there, that's what we call the mate station. That's where they're fitted out. As they come off that mate station, they've got everything in them, rather than they've got to go away and get their livery painted on them and so on. They then have some testing they have to do on radar cross-section, etc. These are just some of the technical challenges. In 2003, obviously if you're going to have a vertical landing aircraft, you're going to have thrust up equals weight down if you want it to hover. And they found out they were 3,000 pound overweight when they went to their critical design review. So they had to redesign at that point the aircraft to cover that and reduce the weight. Australia played a fairly big part in helping on that, by the way. And so on the top left you see what they were intending, and on the bottom right you see what they ended up doing. And that took a while and brought some criticism. What I would say after 55 years in defence deals with the leading edge technology all the time because you're trying to get the capability edge. It's absolutely normal to run into problems when you're doing things because you're trying to do things that have never been done before. And so, people often are so critical about defence. They're always having trouble. It's not because they want to, it's because, or even bad management, it's because you're trying to build something that's never been done before and to get your warfighters the best capability they can have. For those of us that have been involved, it gets a bit frustrating. Just another part of the test, and this is into my area of avionics and radar and electronic warfare and infrared and optical systems. We had a flying lab for the program. You can see there, if you look down the bottom left, they actually built the front of this 737 to look and to be a replica of the front end of an F-35. The aim there was that we could fit antennas and radars, etc. We had a cockpit set up inside the aircraft, inside, it wasn't actually flying the 737, but we could operate all the mission systems and so on. And we had at the back there and all those seats, if you see in the top right corner, they were all engineering workstations, so we could do real-time software development and make tweaks and changes to get the systems tuned. There were 27 different labs involved in the F-35, and this was a flying one. That would go out, we could collect gigabytes of data and come back and they could analyse that and make improvements. Another technology that's been introduced is no longer head-up displays. Displays now are projected into within your helmet. In this helmet there are two cameras doing the projection onto his visor. They give you the information not as a two-dimensional screen, they give you the information in 3 dimensions where it exists. So I was flying a flight demonstrator in Washington on a mission. I was over Pax River and Maryland in the scenario, and they had 2 hostile aircraft come into my view. They didn't come onto a screen or anything, they came on, I just saw 2 red icons flashing, and that was the aircraft detecting those, picking them up and warning me that they were there. They were red because they were hostile, and then I could make a judgment as to whether I wanted to worry about them or not. The helmet also has a system on board, or the aircraft has a system on board called the DAS, Distributed Aperture System. They've got cameras looking out in all directions, and so like a globe around the aircraft, they can see infrared-wise what's going on everywhere. If something comes up behind them, they can launch a missile even and shoot down people at the back because it's been detected. If they see an infrared, 100 milliseconds of an infrared burst, there's a missile being fired. But the other thing is that they get video from those cameras, and that's projected into your helmet. If you look down, you can see through the aircraft because the image is put on in a way that it replaces your visual view, and so when he's vertically landing he can be looking between his legs at the deck of the ship or whatever. If you look out over the wing, and you can see through the wing to the terrain below you. It's as if you're sitting in space. And so this helmet is a specific helmet. They cost about $400,000 or $500,000 each. Martin Baker make the eject seat, which they do for a lot of aircraft, particularly Allied aircraft. They have one for the F-35. When Glenda and I went to the air show last year, we spent some time with Martin Baker in the corporate tent, or the corporate restaurant they had set up on the air show. A magnificent company. They've got a sign outside their production plant with the number of lives saved through ejections, they've not lost a life in an ejection ever. And the number saved, the last time I looked, that people that had safely ejected was about 730 since they started production. In this case, they've extended the physical scope of people that could be flying the aircraft and not suffer damage or injury if they eject. And you can see there from a 103-pound small female to a fairly hefty 6'4" male. They can all fit in the aircraft and successfully eject. This is not an F-35 picture, but just generally making a comment. As I mentioned before, the aircraft no longer requires all that special protection when it's not being used. Now they can take them to sea and they'll get wet like these do. As you can see here, waves will break over the ship. And when I worked for Navy with our helicopters, at one stage there I was out on one of the frigates and we're doing a fleet entry into Sydney Harbour for the 75th anniversary of the Navy. And Prince Philip was taking the lead, but there was a big sea, and at one stage I was on a deck and the ship behind me was, we were 45 degrees over each, and so that the angle between us was 90 degrees. And you can't have aircraft sitting there. And on the Seahawk they have a spike that comes down that gets trapped in a bear trap, and then they can fold the blades and they run it on a railway line into the hangar. This is the demo when they had to demo the capability. What you're looking at here is the aircraft demoing officially the first demonstration test to the US DoD, Department of Defence, to show its ability to. It came in supersonic and then landed. Then he did a vertical takeoff from zero. Obviously his weight would have been, allowable. I've interviewed 6 test pilots that were involved in this as part of the book, where we've collected all these interviews, and he was saying he was only supposed to go up about 4 or 5 feet off the ground and went back down. It sort of got away on him and went up, so he decided to do it twice and then got reprimanded for showing off after he'd done it. But they are impressive to watch. Okay, this is HMS Her Majesty's ship Elizabeth II. This is now the ship that the Royal Navy and the Royal Air Force fly from. Air Force now go to sea in the UK with the B models. I think they've got about 125 stables. The aircraft carrier was Prince of Wales and the Queen Elizabeth II, 2 new ships that have just been recently commissioned. They're carrying, you can see there's about 14 F-35s on this one at the moment. But to show you the interoperability aspect of it, on their first voyage, they operated with 3 different services: the US Marines, the Italian Navy and the Royal Navy. and therefore it's operating off the one ship, and they've never been able to do that before. And so that's one of the beauties of this interoperability and having a common aircraft. Everybody knows what exactly they can do. They are not identical in their capability. There is what we call multi-layer security. Depending on who you are internationally, you may not get full capability on some systems because of security. Obviously the US has the top limit. Then the Five Eyes countries, which is Australia, Canada, the United Kingdom, have the next layer of capability down from the US, and we don't know what they've got that we can't see. So, but they're very capable. This carrier, by the way, there's 2 superstructures on it, which is apparently helps them also. The Ark Royal, when she was sunk in World War II, had 1 engine room. They got hit, they couldn't move it. They've now got the ability to have 1 hit and still move. That's just another view of it. You can see the ski jump on these. They use it. Any of you ever followed this? There was an accident where they lost one F-35. He went up and ran out of power and just fell off the edge. What they'd done is left an engine cover had been sucked in, and he lost his thrust, and so they lost one. A bit embarrassing. There's another one that crashed into a carrier. That was pilot error, where he actually came too low and hit the front of the deck and bounced down and caught fire, and but he banged out. I think he was okay. This is the Italian Cavour carrier. They've got 2 aircraft carriers in Italy, and they've got their F-35s obviously going to operate off this. Inflection points. An inflection is a turning point. Some of you, I didn't know what it was, but there it is. It's a mathematical term in the middle of where something changes direction. That's an inflection. In general terms, in business, it's where something changes and causes taking a different direction. In 2010, this is where I became involved. They have a legislation in the States called Nunn-McCurdy. The Nunn-McCurdy was that if your project exceeds a certain cost growth over a period and a certain time slip, the US DoD have to go to Congress and explain why it's happened and whether it's important enough to continue to fund or to maintain. They had a breach. It was more technical because Tom was the manager of it, and he said what happened was that I think the US Air Force cut their numbers of aircraft they were buying. Well, if you cut the numbers and the cost stays the same to develop them, your aircraft per unit cost is going to increase. And so it was more a technical failure than a real cost increase, though they were more expensive than they should have been. They did a review, and I got involved after these 100 independent experts came in and reset the program. They got another 3 years of schedule and about another $4 billion worth of funds to continue development. So it worked in their favour. Actually, those specialists came from both the department and industry, and in our interviews with them, they were all fairly appreciative that they had that opportunity and they got it right the second time. My co-author, myself and Dr. Betsy Clark, we participated. We did our review, and we were the first independent review team to come back and say that we believe the program would be successful, that it was heading, and we had no doubt about that, even though some of the senior people here in Australia didn't agree with us, but as it turns out, we've been proven correct. The US liked what we did, the way we did it, and so I was invited back over a number of years, and we did multiple reviews and of the program for the US DoD as well as for Australia, and even to the US Congress, when they were having problems, wanted another review. They congressionally mandated it, and Australia was the only country to participate on that, myself. No other country, other than the other 8 countries, never got invited. This is just a team. We were at Eglin Air Force Base looking at the facilities, and Air Vice Marshal Colin Thorne in the middle there. He was General Manager of Aerospace at the time in Defence. my other co-author is the lady in front of him. Beside him is Dr. Betsy Clark. There's the ejection seat. You notice the cockpit opens with the canopy going forward. It pivots at the front. There's a couple of reasons for that. There's one is that they can take the ejection seat out and not have to remove the canopy, which you do on most aircraft. It's a maintenance aid. It also, on a Stovel, of course, they've got the fan behind there, so they don't want to be mucking around too much at the back of the seat. You might have noticed there's something missing out of the middle there. There's no control column. So they fly this with a couple of handheld joysticks and operators. And you notice there's very few instruments. In fact, there's none. That's what is there. There's what we call a panoramic cockpit display. That, remembering they're getting a lot of information in their helmet, in their eyes, sent to them. They can have 11 different segments on this touch screen display where the pilot can call up a range of information. Whatever he wants he can ask for, and he touches it and it'll come up. He might want to know what his bomb load is, or he might want to know what weapons are on, what pylons, or whatever it is. That's all available to him. Just to explain fifth generation, we have what we call fusion. Fusion is where you take all the sensor information and you synthesize that together and come up with a solution about what the tactical situation is. Today in 4th gen aircraft, pilots have to interpret their radar, their electronic warfare systems, their infrared systems, and make their judgment about what's a threat and so on. In the F-35 they don't. The computers do it for them. The systems identify the threats. They have lookup libraries. They have signatures of electronic intelligence signatures of all the vehicles that are in opposition. And when they get a paint on something, it'll go into the library, look it up and say, that's a MiG-25. They tell the pilot. And that's how they know what to display in his helmet. It's red. Not only do they fuse his own sensors in his own aircraft, we now send the information from every aircraft to every other aircraft in the wolf pack. So everybody's getting everybody's display information, and that's being synthesized into solutions as well. So you might have 4 aircraft flying, I don't know what separation, I'm not a pilot, but they might fly 30 kilometres apart. That means you've got 120 kilometres of radar coverage and stuff in front of you. So their situational awareness is fantastic. They're data nodes, so they're on the network. They can relay that to any other warfighter unit on the ground, on ships, anywhere. So the fusion capability in an F-35 is the first time. That's it'd be similar to something like a wedge-tail surveillance aircraft could do. This is the rig where they do the shake and bake. This is to simulate fatigue. They run all those orange poles there, hydraulic vibrators. They can simulate thousands of landings and so on. They've tested that aircraft that was there when we were there evaluating what they were doing. The aircraft, as I said, life is 8,000 hours. They tested that to 3 times its standard life. So that was tested to 24 hours. That helps them find bad design defects where fatigue would cause a problem, so they can rectify those and change the design to compensate. This is what we call an anechoic hangar. You can see that aircraft, they lift them up, they put them there. They have a radar where I'm looking from. They'll paint that and then measure the return, so they can check that their stealth capability meets spec. Behind there, that blue material, radar absorbent cones, so that you don't get the signal bouncing back. It absorbs the incident signal. This is Brendan Nelson and Downer and people signing the contract back in about 2002. And these are the people that helped make sure it happened. And I worked for a number of these. Most of you probably have heard of Sir Angus Houston in the middle. He was Chief of Defence Force. He was a strong advocate for the F-35. There were people that were arguing against it. We spoke to Angus not too long ago as part of our book research and said, he'd retired by then, but we said, what's feedback are you getting off the Air Force? And he said, the Air Force are happy, and he said the aircraft has exceeded their expectations. And you don't hear that very often. I'm convinced we've got the right aircraft. The other people there, my boss was Dr. Stephen Gumley. He was the head of the Defence Material Organisation. And just another interest, down the bottom right-hand corner is Kath Roberts. I worked for Kath a couple of times, and she was the first space commander in the Royal Australian Air Force. So she's just retired in the last month or two from her career. She's an engineer, and so she was the first space commander in the RAAF, looking to manage the space assets. 2017, they brought two out to Australia to the Avalon Air Show, demonstrated them, and a couple of Australian pilots brought them out to prove that they were there, real. There's a couple of links there. If you're really interested in the F-35, it's a very simple link. You can see just f35.com, no dash, just f35.com. There you can get history, photos, media kits, status, statistics, and that's a really good place to go if you want to find out what's happening and what's happened. That reports on each country. That site is run by Lockheed Martin. Quite a lot of information there. The other is our bookshop site. We as authors of the book that you've got there for the raffle had to buy 5,000 of those as part of our publishers. Authors don't make money from selling books. Publishers make money, and literary agents and shipping people. I had 100 or so books out here which I sold for friends and so on, but getting them out now, one book costs $55 Australian to ship from the USA. And when you get it here, if you send it off to someone, there's another $10, so $65. You can go on to Amazon, eBay, or dozens of other sites. If you go on the web and just look up the book name, you'll see probably 100 or more sites selling it around the world, and they can sell it at half the price it costs us to get it here. Yeah. So I don't have books to sell, and we don't know how many we've sold at the moment, but the book's rated at 4.5 out of 5 on Amazon. A few months ago that sold over 2,000 of them, but they were doing a reprint, so that was a pretty good sign. The book is not meant to tell you about the F-35. There's hundreds of books out there that will do that. The book is meant to tell you the human story. It's about all the issues they faced, all the problems, the technical problems, and how they overcame them. It's a report of 100 people we interviewed, apart from our own experiences. The book talks about, you'll see every senior general that ran the program, you'll see the leaders of all the countries, military forces that are operating it, all talking about it. And it's very informative. I think we've recorded all those interviews. I think we've got a capsule in time of a program that would be worth its weight in gold in some sort of research environment. So one day maybe we'll offer that. Anyway, that's it. I hope that gives you a better understanding of your new strike fighter that's looking after us.